Welcome to the DIY Honda Garage channel. The DTC P0116 indicates a problem with the Engine Coolant Temperature ECT Sensor 1 circuit. This particular issue arises when the Powertrain Control Module PCM detects that the sensor output voltage does not align with expected values. In a normally functioning system, as the engine coolant temperature increases, the sensor's resistance decreases, leading to a corresponding drop in voltage detected by the PCM. However, if these expected changes are absent after a specific duration following engine startup, the PCM determines a fault has occurred and sets this diagnostic trouble code. Understanding the workings of the ECT sensor is key to diagnosing this issue. It plays a crucial role in regulating engine performance and efficiency by providing temperature readings to the PCM. The sensor is located within the engine's coolant passage, making it susceptible to various factors like connections or physical damage. When diagnosing, it is important to follow correct procedures since improper handling might further complicate the issue. The Engine Coolant Temperature ECT Sensor 1 is critical in monitoring the engine's coolant temperature, providing vital info to the Powertrain Control Module PCM for optimal engine management. Positioned within the engine's coolant passage, the sensor works by varying its resistance based on the coolant's temperature, which in turn affects the voltage readings sent to the PCM. The system uses an internal pull-up resistor in the sensor circuit to help supply approximately 5 volts to this sensor. If the PCM does not receive a voltage signal that correlates appropriately with coolant temperature changes, it triggers the DTC P0116. Essentially, if the signal voltage remains stagnant, signifying no difference in temperature readings, the PCM assumes there is a fault in the sensor or its associated wiring. This failure affects the vehicle's performance, leading to poor fuel efficiency and potential overheating if not addressed timely. Several factors can lead to the triggering of DTC P0116. First, a failing ECT Sensor 1 itself is a primary suspect. These sensors can deteriorate over time or suffer from environmental damage, leading to inaccurate readings. Secondly, faulty wiring connections linked to the sensor can impede proper communication between the sensor and the PCM. This could be due to physical wire damage, poor connections, or shorts that interrupt the electrical flow. Lastly, while less common, a malfunction within the PCM can also result in this DTC. The PCM may fail to process the input signal from the ECT sensor due to internal failures or software errors. It's crucial to systematically eliminate each potential cause through thorough diagnostic processes, ensuring that all connections and components are evaluated. When DTC P0116 is present, drivers may experience several noticeable symptoms. One of the most apparent issues is engine overheating. If the ECT sensor fails to report the accurate temperature, the engine may operate without proper coolant management, leading to excessive heat buildup. Additionally, poor fuel efficiency can occur as the PCM relies on accurate temperature readings to optimize fuel injection and air-fuel ratios. In such scenarios, the engine might run richer than necessary, wasting fuel. Further compounding the issue, the check engine light will illuminate on the dashboard, signaling to the driver that an issue has been detected. In more severe cases, if the cooling system fails entirely due to faulty readings, this could lead to catastrophic engine failure if the driver unknowingly continues to operate the vehicle under these unsafe conditions. The first step in troubleshooting DTC P0116 involves starting the engine and allowing it to idle for a minimum of 36 minutes. It is essential that the vehicle is fully warmed up during this process, as this establishes a baseline temperature that the PCM can interpret. Alternatively, the vehicle should be driven for at least 4 miles to ensure adequate operation of the ECT sensor. During this phase, pay close attention to the sensor's output. You may need to use diagnostic tools to monitor the ECT readings and compare them with expected values. If there are substantial discrepancies between the sensor's readings and the actual coolant temperature, this could confirm a faulty sensor or wiring issue. Documenting these steps accurately is vital before moving on to further diagnostics, as this forms the groundwork for concluding whether the sensor or associated wiring is the culprit. After completing the initial running phase, the next step requires pressing the engine's start-stop button to select the off mode. It is important to wait precisely 10 seconds before restarting the engine. This brief period allows the PCM to reset and reinitialize the ECT readouts. Once the engine is restarted, observe the ECT sensor's performance for at least 10 seconds. Keeping an eye on how the sensor responds to the changes post-restart is crucial. Evaluate if there's a consistent voltage output in response to the expected coolant temperature variations. This step checks if the sensor can maintain stable readings under varying conditions and confirms if the initial checks provided accurate data. Proper logging here assists in making an informed decision on whether a replacement is warranted. After any repairs or replacements made regarding DTC P0116, the final verification process is crucial. Start by running the engine to observe its performance, attentively monitoring the ECT readings through diagnostic tools. This stage ensures that the system is functioning as intended and that the coolant temperatures align with the inputs expected by the PCM. Check for any recurrence of the DTC after normal driving conditions have resumed. There should be no dissonance between the coolant temperature and the ECT sensor responses during final assessments. Ensuring that the check engine light has remained off is also vital for confirming a successful repair. This approach provides assurance that the underlying issue has been effectively resolved, allowing for a return to safe operating conditions. To minimize the chances of experiencing DTC P0116 in the future, implementing preventive maintenance measures is essential. Regular inspections of the ECT sensor should be conducted, looking for physical damage, corrosion, or wear that may lead to inaccurate readings over time. Adequate wiring connections must also be inspected to ensure they remain secure and free from wear. Environmental factors can impact wiring quality, so keeping these connections clean and protected will help ensure functionality. Additionally, performing routine coolant system services is advisable. This not only involves checking the coolant fluid levels and quality, but also flushing and replacing old coolant as needed. Properly maintaining this coolant system can significantly increase the lifespan of components such as the ECT sensor and prevent the unfortunate occurrence of related DTCs. In conclusion, understanding the function and operation of the engine coolant temperature (ECT) sensor is vital for diagnosing DTC P0116 effectively. The specifics of troubleshooting this problem emphasize systematic checking of sensor performance and wiring connections. Following the outlined steps allows for a structured approach to identifying potential failures and addressing them before they escalate further. Additionally, adopting preventive maintenance routines will greatly reduce the likelihood of experiencing this trouble code again in the future. Knowledge of these factors gives not only peace of mind, but ensures the vehicle remains in optimal working condition. Always remember that routine checks can save time and costs associated with significant repairs. Please like and subscribe to the channel. See you next time.